Welcome, boys and girls, to the fourth and final episode of the navigation and flight planning series. This video will be focusing on the flight planning portion of this task. Thank you very much, guys, for watching this video. Thank you for sharing it, and I really appreciate it. We are trying to get this information out there to as many people as possible, so please continue to share, like, comment, and let us build this channel together. If this is your first time on this channel, we would like to welcome you. This channel is all about aviation and inspiring future aviators, so please consider subscribing. If you have not watched the first 3 videos, please pause this video, go back and watch those 3 videos, and come back to this video. You are going to thank me later. With that being said, let us get started. Before we complete our flight planning portion or our flight plan, there are a couple of things we need. E6B router. I got this one off of Amazon. This is the CPL RX and it's from ASA. You're also going to need something like this. This is a generic POH. Now, your POH comes with your aircraft model. The difference between that and this is one is certified by the FAA and the other one is not. All of the information you will find in the POH, you'll also find in this book. Well, I'm forgetting the most important thing. You will need a sectional chart. So first thing first, at this point, you already know what airport you'll be coming from and what airport you'll be going to. For the purpose of this video, we will be taking off from Jimmy Carter Regional. Identifier is Alpha Charlie Juliet to Thomaston, and the identifier is Oscar Papa November. Now we know our departing airport and our arrival destination airport. First thing we need to do is go on the computer and look at the weather. All right, guys, we're on the computer, and as you can see, we are on weather.com. Some of you might be asking, why are we on weather.com instead of aviation weather? Yes, in the previous video, I stated that the official weather website for aviator is aviationweather.gov. But that doesn't mean you cannot go outside of aviationweather.gov to get more information for your flight planning purposes. Aviation weather gives you forecasts up to 2 days. Well, your local weather channel gave you up to 10 days. So this is why I like to come to my local weather channel to see what the forecast will be for the next 10 days. So what I usually do is I come to my departure airport, look at the weather. For example, in this case, the flight will be conducted around 5 p.m. today. So what I would do is come to 5 p.m. As you can see, there are thunderstorms in the area around my time of departure. This is not an ideal weather for me, given the fact that I'm in a Piper Warrior and I don't want to get into a thunderstorm. But for the purpose of this video, we're going to use this weather. After that, I go to my destination airport and watch the weather at 6 p.m. Yeah, there's no thunderstorm. The wind is not too bad and the chances of raining is not bad. It's pretty cloudy, they say. But again, this could not be an ideal VFR flight weather. But hey, for the purpose of this video, we are going to continue with our flight plan. What I do next is go to a couple of airport or city on my route and find the weather and see what the weather is doing. After that, I come to aviationweather.gov. When I get to aviationweather.gov, I take a look at this page. This will kind of tell me firsthand what is going on. Like any convective activities going on, you'll find it here around your area. I can see there's something going on here, but as you can see, for the most part of the United States, there's nothing going on. In this area here, as you can see, they have convective activities going on. Where I spend most of my time is the forecast and the observation. Forecast is prediction, observation is what is going on, what they observe. So on the forecast section, I come to winds aloft. Guys, if you guys want me to do a detailed video on this section on reading your forecast, please let me know in the comment section below. So as you can see, when I hover over a region, it's highlighted. This flight will be conducted in the southeast. I'm going to click on it, and then I can find the airport around me or the airport on my route of flight that has a weather station that produces winds and temperature data. So I'm going to go to ATL and CSG. Now I can use this weather information here to compute my magnetic heading, ground speed, and all of that good stuff. The wind is 27014, 2719. So I'm going to write all of this information down and then come to 6,000. Now with 6,000, they have started adding temperature. I think the reason they are not giving you temperature here is because 3,000 is closer to the surface, so they want you to use a surface temperature. So for that, we are going to go to our TAF. TAF stands for Terminal Area Forecast. So again, you have to find the station around you that produces TAF. So in this case, we're going to go to MCN and WRB, get the TAF information. So when you come here between 2100, becoming 2100 Zulu and 2200 Zulu, it's saying my wind will be coming from 250, 10 knots, gusting 15. In this case, I'm going to take 15 knots because that's the fast speed right now. One important information that is not given here is our temperature. So I'll come here and get the TAF information. Here they're saying the temperature is 21. Okay, so I'm gonna put 21 in here. Alright guys, with this information, let's go back to the sessional chart and start computing our magnetic heading and ground speed. Alright guys, welcome back to the sessional chart. We got our information. The next thing we need to do is find our true course. And to do that, we need this, our aviation router. So what you're going to do is line up your airport, your destination and your departing airport. Line it up straight. Make sure it's as straight as possible. And take your pencil and draw a line. Simple as that, my friend. We have drawn our true course. The next thing, we have to know what degree our true course lies on. Yeah, we have the line, but what degree the true course lies on. That's the center of the router, and put it right over your departing airport. Now on the sectional, you have a line of longitude and a line of latitude. Line of longitude runs north to south. Line of latitude runs east to west. So the horizontal line is your line of latitude, and the vertical line on your sectional is your line of longitude. In this case, on your router, you have a line of you have a horizontal line, right? So for this video, that line lies closer to my airport. So I'm going to line up this with my router while keeping the center of my router over my departing airport. On the router, you're going to see two pointing dark arrows, one to the east, one to the west. What is your east heading? It's 090, right? So line up your 090 with your eastern heading, and that will automatically line up your western heading with 270. And if you line everything up well, you're going to see that your latitude line is also lined up with this arrow on this round circle on your router that's pointing up. So you come on top of the router and see what degree that lies, your true course lies on. See, on the middle of my line, I'm seeing 350 here, and the next one right on the middle of the line is 355. So my true course lies on the 355 degree. So I'm going to come here. So I've been writing on this thing. So I'm going to put TC here equal 355 degree. Now the next thing is to find what we call our true airspeed. And with that, this is when we introduce our POH, if we have it with us, or our generic POH information menu. This one is for Warrior because we're using Warrior today. Okay, this the aircraft will be using. This is a PA 28-161. I don't know what aircraft you're going to be using. Find your aircraft model information, type it on Google, and you type in generic information menu. Something should pop up, and you should find this on eBay or Amazon. So pull this up and go to your performance section. In this case, my performance section is in section 5. See right here, they have section 5, performance. And I want to go to my engine and cruise performance. Well, when you come to there, you have 3 sections. You have power at 55%, power at 65%, and power at 75%. I personally use power at 75% to plan my flight. Power at 75% telling you your best gas mileage will be 11.4 gallon per hour. I'd rather go with more fuel than less fuel. When you come to your 65%, that gas mileage goes down to 9.2. If you plan your flight using 65%, and while in flight, weather changes on you, and you have a strong headwind, that will mean more power to continue. More power meaning more fuel you're going to burn. So if you plan with less fuel and you're burning more fuel, the chances of you running out of fuel mid-air increases. So that's why I use this. If weather change on me and I have a tailwind, I can reduce my power to 65, and guess what? I still have enough fuel to get to my destination. So yeah, I always plan with this. For the purpose of this video, we are going to be planning for 4,500 for flight altitude. When you come to this section here, we have 4,000, we have 5,000. We do not have 4,500. So like the weather, we're going to try to interpolate what our true airspeed is supposed to be at 4,500. Based on our temperature we chose, so we're going to find 28, 27 is closer to 28. So that's 114. And here 25 here is closer to 28. So I'm thinking 114. So true airspeed equal 114. Now we're gonna have to come up with 2 different true airspeed. This one we just found here is our cruise performance. For this one, I usually use my VY, my aircraft VY, which is for this aircraft is 79, let's just say 80 knots. So if you are going 80 knots indicated, you're pretty much going 80 knots over the ground. And with no wind condition, your true airspeed and your ground speed are equal, are the same. So I'm saying that I'm not taking up with a heavy tailwind or heavy ground headwind. So this 80 knot will do. Use your aircraft VY. The next thing here is we already found our true course, right? The next thing we need to do is find our true heading. And for that, we will need our good old E6B. As you can see on the E6B, you have line going up and down and line going left and right. This line, between those lines, the one that go left and right, they are 2 degrees apart. The one that go up and down, they're also 2 degrees apart. You're going to find out why this is so important to know. So we come on here to say, just follow for ground speed and true heading. We're going to follow this information. Okay. They say place wind direction on a true index. This is your true index. It says on a true index. So let's put our wind direction. What was our wind direction? We are using our surface wind. So our surface wind is 250 at 15. Okay, let me put this pencil down. 250 at 15 now. 250. Mark wind velocity up from center. What is our wind velocity? It's 15 knots. Good. So if you have 10 here and it's 2 degrees apart from each other, so this is 10, 12, 14. 15 will come right in the middle of 15 and 16. So, now this is why we use pencil, not pen. It's hard for pen to write on this thing. Is so slippery. Pencil will give you a good mark. Place true course on a true index. Our true course is 350. So we're going to line this up with 350. Sorry guys, I'm trying my best to not block you guys' view. So 350. It says slide wind velocity to true airspeed line. That is why we found out, we went ahead and found our true airspeed. We're going to slide our wind velocity, the 15 that we marked, to our 80. So we are 100, so 80 will be below, right? So be careful, don't shift this. So I'm going to come here to 80 knot, and then it says read your ground speed under center. My ground speed here is around 79, 80. Ground speed GS equal 80. Remember I told you guys earlier, true airspeed and ground speed are the same in no wind condition. And then under that it says read wind correction angle between center line and wind velocity mark. Again, these lines are 2 degrees apart. So I'm on 2, 4, 6, 8, 10. So my wind correction angle, WCA equal 10 degrees. So with this information, we can go now and find our true heading. True heading here says your true heading TH equal your true course plus or minus wind correction angle. If this point you made end up to the left, you have to subtract. So that is, you are left, the wind is coming from left of your course. If it is right, you have to add. That means the wind is right of your course. All of this thing is to help you keep your ground track. So in this case, we are 10 degrees left. So I'm going to subtract 10 degrees from my true course. My true course was 350. So 350 minus 10, that's equal 340. So now my true heading equal 340. Are we done yet? No, we have not. Our main goal is to find our magnetic heading. Now on this here, our magnetic heading equal the true heading plus and minus variation. On your sectional chart, you're going to see these magenta dotted line. So it's purple dotted line, and you're going to see at the end of it, you're going to see a 5W or 5E, which stands for 5 west or 5 east, or whatever number that will be on that. Here on this one, I have 5 west. If you have west east, it doesn't matter. What matters is come back to this E6B and say what it says. It says if you have east variation, you subtract. If you have west variation, you add. So we're going to add 5 degrees to our true heading. Our true heading was 340. So 340 plus 5 will give us the magnetic heading of 345. So our magnetic heading here is 345. This is the heading we're going to use to navigate to our destination airport. This is the heading you should see on your directional gyro or your magnetic compass. Alright guys, we just finished the first puzzle of finding our magnetic heading for the type of climb. Remember, we got two true airspeed. We have type of climb and we have cruise. Now, when we get up to cruise altitude, our wind will be coming from a different angle. So therefore, we need a different angle, wind correction angle. It could be less, it could be more, depending on the strength of the wind and where the wind is coming from. So I interpolated the wind at 4,500 to be at 260 at 28 knots. Temperature is 11 degrees. So you have to go through these steps using the wind information from your cruise altitude. So let me go through it, and I'm going to fast forward this. Alright guys, I went through this process, and for our cruise speed, when we cruise altitude, when we get to 4,500, we have to change our heading from 345 to 341. We are actually going, even adding more correction to be able to keep this grand track. First we're going 345, now we have to go 4 degrees to the left again to continue with our ground track to get to our destination airport. Alright guys, this is it for this video. I hope this video was helpful to you guys. If you have further questions, please leave it in the comment section below. And one thing I didn't introduce in this video is the flight log, and I did that on purpose. The reason is I wanted to wait until we get on the aircraft weight and balance, which in this case will be our next series. Okay, you wouldn't want to miss those videos. So please, if you have not yet done so, subscribe and hit that notification bell, so when I upload new video, you will be notified. So that's it for this one. I will see you guys in that video. But until next time, stay safe, stay proficient, stay current, have fun flying, and always remember to keep the blue sky up.